My name is Matt DeBergalis. I'm one of the authors of Meteor, and I wanted to just take some time to walk you through some of what we've done. It's a very new project. We launched, I guess, 6 or 7 weeks ago. So what we have built is a radically faster, radically easier platform for internet-scale JavaScript applications. I want to spend just a little bit of time talking about kind of what we were trying to imagine, and then most of it just playing around a little bit with the code, showing you how we can build something simple as we go. And my one request is that you interrupt with questions, because I'd much rather just chat about this and that than drone on for 40 minutes at the end of the day. So a little bit of motivation about where we are. The way I look at the world is that there's been this interesting oscillation between eras when we render user interfaces on the client and eras when we do it on the server. And we can go all the way back to like the PDP-11 days when we had these massive computers in server rooms, and they spoke some sort of protocol over a wire to a dumb terminal. So all of the work of the UI and rendering the screen was done on the server, and then you talk 3270 or VT, and you end up with this terminal that shows your display. And then in the 80s, CPU power got cheap enough that we could move processing to the desk. And what happened was, with the rise of Windows and some other things in the same era, we were able to make much better applications by moving the brains of the app from the server to the client, right in front of the user. You could just make a much better interface. So we threw out all of the old dumb terminal apps and replaced them with these beautiful Windows 32 apps and this desktop experience that people liked. The web era came along and undid all this because it had some significant advantages for ease of application delivery, and you could type in a URL instead of buying CDs. But it was actually a step back, right? I mean, the interface got dumb again because the browser, which is really just a dumb terminal in the mid-90s, was rendering these fully displayed screens from the server. And what's really exciting is that we're finally going back to this better space where we can put the user interface back on the client. And it runs in the web browser now. It's written in JavaScript, which is basically an operating system for the modern era. And the question is, how do you build an application against that technology? So what's the equivalent of what we built in the 80s and 90s with all of this exciting desktop software? And the way I think of Meteor is we're going to try to do what the relational database did back in the 80s and 90s. So look at what everybody's doing today. We want to write these rich JavaScript applications. So we write it with Node or Rails on the back end to serve our API. We definitely want to use Node for some sort of invalidation server to notify each client when the data is stale. We build some sort of local client store running in the browser. We use something like Backbone to structure all that code, right? There's all these technologies that come into play. And what I find is you end up writing the same stuff every time. You can think of it as like undifferentiated complexity, right? There's all this technology that we have to build just to get started, just to have an application that runs in the browser, that feels fresh, that updates, that's fast, that has the data when it needs it, and so forth. And a lot of that, I think we're at the point where we can factor that out into a framework. And that's what Meteor is. It's a set of technologies that takes these hard problems that have nothing to do with the application, things like distributed cache invalidation or real-time page updates, and moves them into the platform so that the application can just focus on the app. And the idea is we can do this in a universal way. So for example, Meteor supports IE6, which I don't expect any reasonable application developer to bother with. But there are cases where that's still important. And by being this framework technology, we open up some options like that I think most people just decide are on the far side of the 80-20 line. So a few principles kind of guide us, and I plucked a couple that I just wanted to talk about. The first one is everything ought to be JavaScript. I don't think there's a lot to say with this audience of why that's important. Number two is it's data on the wire. That's the future. It's data on the wire, not HTML. There may be an exception for initial page load because that's how the web works. But once your app's running, we're talking about APIs and data flowing back and forth continuously, not pages that the server is generating. That era is going to end. We think it's very important that APIs be simple, that systems be simple. So in Meteor, we've carved everything out into separate modules. Each of them has a specific purpose. The code we try to make very accessible and clean, and those interfaces are clean. We use the underlying technology. So you're going to use Mongo or maybe another database, but it's an existing technology that you can use. Whatever template language you like. Those are things that we want to bring forward into the new world. And I don't know how best to say it, but it ought to be fun. It ought to be magical. I was talking to a guy in IRC a couple weeks ago, and he said, I hadn't had this much fun since I used my TI-99 in 1981. I had never heard of this thing. There's apparently this like 16-bit home computer in 1981 that this poor guy hasn't had fun since he was able to fool around with that thing. So we've done something, I guess. But it is. We've tried to make it really enjoyable to use Meteor and to make it a pleasant experience instead of a frustrating one. So let me just mention a couple major technologies that are in here, and then we'll get into the code. So the first one is what we call Live UI, which is a technology that sits underneath whatever templating language you like that gives you real-time page updates. So the goal here is whatever data you're looking at in terms of drawing on the screen, when that data changes, the screen should redraw. You should not have to write callbacks. You should not have to write bindings to manage that redrawing. And we should be very careful about how we do that. So for example, if you're typing in a form and there's a redraw, we shouldn't disturb what you're typing. Another piece of this is that event handlers ought to talk about the data that they're referencing, not these DOM nodes, which is just a function of the display. So you'll see what I mean by that in a minute. So that's a set of tough technologies we call Live UI. The other thing I want to mention is what we call live data, which is this challenge of how do we move data in and out of a rich client application. Because the problem here is that your app is on the far side of the internet from your data. And if you wait for round trips when you're rendering, the experience is horrible. So the goal is to compensate for that latency by doing some things with the structure of the application that let you write your app in the client as if the data is always there. But in reality, you're talking back and forth with a server where the real copy lives. So the way we do this in Meteor is that clients subscribe to sets of data that live on the server. This is different from REST, where you're getting a snapshot. A subscription is real time. You're always getting updates to data as it changes. That data gets stored in a cache on the client. And we're going to give you the same database API for that cache that you're used to using on the server with your real database. So by default, that's Mongo, and that's what I'll use today, but you can use anything. When you want to change the data, the answer is really simple. You call up the server and you say you want to do something, and the server does it. So that's also actually the security model, because that's the place where the server can impose whatever policy it wants. If you don't want to wait for the server, it turns out most of the time the client can also simulate that change immediately without waiting for the server, because it knows what's basically going to happen. If I want to add a comment on Facebook, I'm pretty sure Facebook's going to let me comment on the story. Maybe if I'm doing something weird in my client, eventually that gets removed. But for the most part, I ought to be able to update the screen immediately without having to wait for the server to get around to giving me an answer. And that's really the future of APIs. It's going to be these real-time data subscriptions, not REST, which is based on this stateless request-response conversation. That was good for delivering documents to browsers. It is not good for delivering data to real-time apps. So we're replacing that with what we call DDP, but whatever it is, it's going to be this session-based view of documents coming back and forth. And so that's what I'm going to show you. So let me stop there and just show you a little bit about how this works. So I'm going to make an app called, well, we'll just call it demo, but all I have to do is type Meteor create and the name of my app. And I can run Meteor. I now have an app running, and I'll bring that up over here. And by default, we just have a little Hello World application. You can click a button, whatever. So what I want to do is actually just erase the code that's in here. And I'm going to build an app that's pretty similar to what we had in our screencast, if you saw that, where we're just going to have a list of players and some scores, just to give you a flavor of what it's like to write in Meteor. So there's only 2 files that I'm going to worry about, plus some CSS. So the HTML that we're looking at, again, as I said, this is handlebars. So I'm just going to say, let's have a single template called players. And so then I'll define my template using this template syntax. And all I'm going to do is let's use the handlebars syntax for each. So I'm going to iterate over some set of players. Actually, I'm going to put this inside a div. I think my CSS wants a div here. And for each player, let's just render a div with class player. And we'll give it a name. And we'll give it a score. Is that it? Yeah. Okay, so that's a pretty straightforward handlebars template. What we have here are a couple of handlebars helpers that are going to pluck data out of the objects we're rendering. And we've got this iterator each that's going to run over a list of players. So I haven't defined that yet, but that's the HTML side of my app. Let's bring up the JavaScript. So I'm just going to erase all the JavaScript here. The first thing we need is a place to store all our data. And because we have Mongo out of the box, let's use Mongo for this. So I'm going to define players as a new Meteor collection. And I want to store that in a Mongo collection named players. And then on the client, because this file has both my client and server code, I can define a couple things. So the first thing I'm going to say is I had a template whose name was players. And then I have this helper function called players. So the name of the template is players, the helper is players, and helpers in Meteor are functions that return data. So all I'm going to return is players.find, and I can use the Mongo syntax to return all of my players. And I save the file, and I have an empty screen. So let's see if this worked. What I'll do is I'll bring up my inspector. Well, that's not going to look good at all. Okay. Okay, so in my little console, can you read that? I'm sorry, that's very small. If I zoom in, it only zooms in the text of the page. I apologize. What I've done here is I've run what looks an awful lot like a MongoDB command. And I've done it inside my browser. And I've just said, create a document with a couple of attributes, name and score, and put it in the players collection. And magically, what happened was that template I wrote recognized that there's a new piece of data that matched that query, and so it put it up on the screen. And in fact, it happened on both browsers. So we're also somehow sending that data up to the server, which is getting propagated back down. So let me, I have somewhere, I think, yeah, let me copy in some CSS. Okay, so if I got my classes right, maybe this will look a little better. There we go. So let me just add a few more players. Okay, so again, I've just run these database commands in my browser, and I get these 3 players. The next thing is let's sort them so that they appear in some sort of reasonable order. So if I go back to my JavaScript, and this is the whole code for the app, by the way. There's no framework glue or any sort of weird stuff going on. And you know, it's tough to do a demo, I think, in just a few minutes. So obviously it's a very simple application, but I just want to give you a sense of like how easy it is to kind of get going and explore some of this stuff. So The Mongo syntax for finding documents, well, the first argument is the selector, and that matches everything. But I'm also going to do a sort order here. And let's just sort by descending score and then ascending name. And I'll save my file. We do hot code pushes, so when I save the data in the JavaScript file, we rerun the browser code. And now I'm sorting by score. What's really nice is that I have a real database API, so I can start to do some sophisticated things with that that end up being more difficult if you've hand-rolled all this code by yourself. So the next thing I want to do is have a way to be able to add to a player's score. So we'll do a couple things. In the HTML, let me put another div, and I think, yes, please. Yeah.
Yeah, so the obvious question is, like, what about security? How are you not letting people just spam your database? Right?
Let me add the score increment, and then we can dive into that, because that's a great. I was hoping someone would ask. The question is about security. I'm sorry. How do we prevent everybody from just updating each other's database? So I'll just add a input button. Is it value? Add 5 points, something like this. Let's see if I got that styling right. Sure. And then in my JavaScript, so I need two things. Actually, I need a bunch of stuff. The first thing I want to be able to do is have a sense of the current player I'm working with. So one other thing over here, let's add a selected helper to the name of my class on that div. So I'm going to come back over here, and I'm going to define another helper, players.selected. And what I'll do here is use session, which is something we give you. It's just a key value store that stays on the client. So session.equals, we'll use the key player ID. And we'll just see if the ID matches this, which is really interesting because this, inside my helpers, is the data object I'm rendering, not anything about the DOM. So I can just check to see if my IDs match. And if so, let's use, forgive me, I can't type here, selected, otherwise just an empty class name. So that's the first thing. The next thing is we can write an event map, so I can say on that same players template, I can define some events, which is just a very backbone-like hash map. And we'll say if I click on something with class player, then session.set player ID. And again, this is going to be bound to the object that we're working with, the actual Mongo object that came out of the database. So I don't have to grovel through the DOM looking for anything. And hopefully, if I did all of that right, beautiful. So now when I click on one of these divs, we see that session update. And if I bring back Safari, you'll see that these are independent. So each client has its own session. And if I change my code and do a hot code push, we preserve that state across the code reload. So this is how you do continuous deployment when you've got lots of users using your application. You want to push new code all the time, but you can't disturb a user. You can't force them to reload their page. That's like rebooting Windows 95, right? That's gonna start to get really old. And the only thing I need now, just to close this story, is, one more event, which is if I click on the button, and so event maps are just the usual backbone style where you've got the type of event and then a CSS selector if you want. And all I have to do here is do a players.update, and I'll update the object with that ID, and I can just use the Mongo syntax for incrementing the score by 5. So I saved my code, and it didn't work. That's too bad. The perils of live coding. Click input. Did I do anything wrong with that? Oh, it's not this ID, of course. Session.get player ID. Thank you. Let's try that one. There we go. So really simple, right? Like there's not a lot here. We've just got some event maps. We've got a declaration of a collection that we're going to use on the client. And just with that, we're able to do some really interesting work with data synchronization and having a really responsive application that, that has that behavior. So let me stop there and get to your question about security and data segregation. So the first thing to talk about is that I mentioned we're sort of recreating that client-server era from the 80s and 90s, which doesn't have a lot of positive associations, I suspect, but there was some great work done back then. So we've got good patterns for how to do this stuff. And the first observation is that we don't trust any of the code on the client. And there's only two things the client can do that matter. One of them is ask for data from the server, subscribe, and the server gets to decide what the client can see. And the other one is ask the server to make a change. In other words, call a method. So the security story for a rich client app is actually really solid. Unlike something like Rails, where you're mixing your models and your controllers and your business logic, and sometimes it's hard to know where do I impose the question of who's doing what action and how do I control that. Here we're just going to say, look, when you run a method on the server or when you subscribe to something, you can decide as the server whether or not to allow that action. So let me show you what subscriptions look like. We're running in what we call auto-publish mode. So Meteor, out of the box, automatically publishes the contents of every collection to every client, which is a great way to do demos and to do prototypes and so forth, and it's a pretty lousy way to deploy an app. So the first thing I'll do is I can remove the auto-publish package. And when I do that, all the data is going to go away, because now I'm under this manual control where I have to decide exactly what I'm going to send to each client. And let me just show you a few things that kind of fit into that, that way of thinking. So the first thing I'm going to do is, back in my code on the server now, let me do a meteor.publish. I'll explain this in just a second. So there's my first publish function. So this says, I want to publish to every single client automatically when they collect this query. And players.find just says, give me all the players. So as players come and go, that's going to return everything back to the client. And so anybody automatically sees all this. So that's the first level that you can do. The next thing we'll do is let's actually call this something. Instead of null, which means give it to everybody, we'll call it all players. And then on the client, I can do meteor.subscribe to all players. Something like that. And we should see the same result. So we're back where we started, but now we have this manual pub sub being set up where the client is asking for a document set called all players, and the server is publishing that. So here's something we can do. We have all the Mongo syntax here that we can use. So one thing we could do is we could say, give me all the documents, but maybe I only want the score and not the name, right? So maybe we want to segregate some of the data. So we just tell Mongo, I only want certain fields back from my database. In particular, I don't want the name. So that's Mongo syntax for doing that. And I do a hot code push, and now the names are gone. And that's not on the screen, right? That's also, if I go into the console, so players.find in my console, that's a database cursor. I can do fetch, which gives me an actual array of objects. So I have 3 objects, and if I open them up, I just don't have any name fields. They're not there. We can overlap subscriptions. So it gets a little contrived, but let's try something. We can say meteor.publish a second set of things. Top players, let's say. And this query, let's just return players.find. And we'll give them all the what we'll do here is let's sort by descending score And let's limit this to just the top 2 players. So this publish says, I'm always running this live query. Whatever the top 2 scorers are, I'm going to publish under a separate name called top players. And let's go subscribe to that too. And now I get this. So the server's governing which parts of which documents I can see. And if I go rerun that query, so here's my 3 player objects. This one only has a score attribute, but this guy has both a name and a score. So you can imagine how you build up using this something where you can say, okay, I've got, let's say I'm implementing something like Facebook. So I probably want to subscribe to all my friends, but maybe I only want their name and the last news item they posted, right? So that's a very natural thing to publish to anybody who's logged in. And then when I'm looking at a friend, maybe I subscribe to a much larger set of information about that person. So these things can overlap very nicely. I have some information about certain people, and I have other information about a smaller set of people. And you might do that for performance reasons, but you might also do that for security reasons. So what I seriously considered demoing today, but I just don't think it's working yet to a stable point, is the thing everybody wants, of course, is auth. And the way that's going to look is that inside this publish function, you're going to be able to look at this .userid. So that's going to tell you who is asking for this particular request. What client is it? And so I'll go off the rails for a second here. You might write something like publish my friends. And what you'd probably end up doing is something like return people.find. And you would force friend IDs. And Mongo syntax lets you just get away with saying this .user ID, right? So this function would say, anybody can ask for my friends, but it's only ever going to return the set of documents from the database that are flagged as actually being your friends. The other half of the story is methods. So let me just erase this for a second. So what I wrote was when we clicked on that button, we incremented the score and we took advantage of the client. And again, in auto-publish, clients can do anything they want to the database, and that gets propagated up to the server. That is not how adults write applications, I know. So what we would do as we wanted to impose security is to start defining actual methods, right? What is a client allowed to do? And so one method might be, add to score. So where am I here? Methods takes a dictionary. Add to score is going to be the name of my method, which is a function. Let's say it takes the player's ID, and it does players.update, just what I had down here. So players.update, and now I'll just use the argument to the function ID, and we'll increment their score. And this is where you would say, if this .user ID is set, if you just want them to be logged in. Or you might say var user equals users.find, this .user ID, which gives me their whole user record. And we'll build some things on top of this for a reasonable set of accounts. And then, if user.admin, then we'll allow you to update their score, something like that, right? So that's all it's going to be. Very, very straightforward. So our method add to score takes an ID and updates the score of a player by 5. And now we'll come down here, and instead of doing a raw database update in my handler, I'll just do meteor.call, add to score, and the argument is session.get player ID. So if that makes sense, what I'm doing now, instead of this raw Mongo update, is I've defined a contract between the client and the server that says there's a thing you can ask the server to do, which is add to their score. And hopefully, if all of that was connected correctly, there we go. So we're back where we started, but now you're under this manual control. Yeah?
So what are the data being transferred over the wire? So when you click the add, so because we send a request to the server to update the data, right? So and then what's being sent back to the client after update?
So the question is, what comes back to the client when you call a method? Is that, did I get that right?
Yeah.
Okay. So whatever you want. So I didn't return anything, but well, there's two things that are happening. So let's distinguish those two, and that's actually a great question. Let's have our method just return this magic string, it worked. Okay? So I'll save the file, and everything's still working. And if I go over to my console, I can do meteor.call, add to score. I'm going to need someone's ID, won't I? If anyone understands why selecting things in... I'm sure you've all been through this.
It's like a subtle.
It is, right? Like,
Slower double click.
yeah. Oh, there it is. I got it. Okay. So meteor.call, add to score. And the arguments, so the only argument to this is their ID. Okay, so now I'm adding to that guy's score, and I can do that a few times, right? So meteor.call itself returns undefined, because this is an asynchronous method call to a server, right? I'm not going to wait around on the browser for it. But we can provide a callback. So I can say, in the normal error result, whoop, I'm off the screen a little bit. Is that all? So error result, and I'll just say, console.log method returned plus res, paren, semicolon, brace, blah, 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 blah. So there you go. So I run the method call. The data, in terms of the new score, that's a subscription. So my browser was subscribed to the list of players and their scores, so that data gets updated. And then the method itself can return a value that I might use for different reasons, right? So depending on what I'm asking the method to do, I also have access to that return value once I call it and the result comes back.
I assume you're using JSON-P there or something similar.
This is running stock.js, so the whole conversation is over that. The other thing I can show you, though, since you asked, that's an interesting question. So we have a new client written in Python that lets you see that conversation about what's being subscribed and calling methods. So I'm very new to this, so I apologize if I don't get this quite right on the first try. So this is running over a raw WebSocket, so no sock.js here. And we've got people writing these clients in a whole bunch of different languages. So you got Python, you've got iOS, which means you can have a table view on your phone that automatically updates because it's subscribed to a Meteor server, and that's a really interesting design pattern, I think. So I can do sub and what did I call it? All players. Let's use top players because that'll give me the scores. So I asked the server for subscribing. Is that big enough? Yeah. So I asked the server, and what I got back were these 4 attributes, right? So the server's telling me set in the players collection the document with this UID, the attribute name score to 125, and the name to Charlie, and then there's another pair for the other player. And I can also sub to all players, since I had that set up, and I'm getting one more attribute, which is on a new document that I hadn't seen before, this DD3E1, and just the score, right? Because the way this is set up is that and then I can do call, and add to score was the name of the, and how does that work? It's a JSON array, I believe. So if I do this right, so there you go. So when I call the method from my client, two things happened. I got back a method result, which was that magic it worked string, and I got back a new attribute because of that score. So let me run this a few times, and let's remember, once this guy has a score more than 70, Matt is going to fall out of that top player's subscription. And so watch what happens. So we'll add to the score, and we're just going to set a new attribute each time with the new score, 52, 57, 62, 67. Watch what happens when I run it one more time. So the server is now giving me the name, because it's now in the top scores query that I'm subscribed to, and it's unsetting the name of that other player who is no longer in that subscription set. Right? So that's sort of a good way to sort of view what's really going on in terms of moving data around and calling methods. Yeah?
What happens if your connection to the server fails? Like you're updating the UI on the guy who's initiating the request immediately?
Sure. So the question is, what happens when the server fails? So here's my browser running. Let me kill the server. So my client complained. I don't think the client implements reconnection, so we're going to close that. But the server's dead now. My browser is still running fine, right? And in fact, I can increment, but I called a method. Okay, so I clicked the button a few times. The problem is I haven't told the client how to do anything other than call the method. So I just clicked it 3 times, and if we remember that and I rerun, what's going to happen is that the client has queued those up. So it's going to take a second. It's doing back off to check to see if the server's alive. But there, 3 more times. There's a better version of this, actually, which is if I take this method out of isServer and I define it on the client and the server, now I'm saying that I want the client to simulate the method without waiting for the server. So I'm going to update my local database by incrementing the score and not wait. And because I'm running on localhost, you couldn't tell the difference because the server is very fast. But you can tell if it's on the internet. So we're back where we were. Everything's running fine. Lisa has 107. I kill the server. Now I can start incrementing my score, right? And the other browser is stuck with this older result. It obviously doesn't see those things. But when I rerun the server, we should see everything sync up in a second. So there you go. So to be really clear, queuing up method invocations while you're offline is not really a good way to do offline support. I think the better story is to use an actual database that's designed for that, like Couch. So that's the direction we're going if you really want an offline app. But this is important. It also speaks, I think, a lot to how do you build a highly available application in this world? Well, the answer is you talk to multiple backends, and the client has some control over how it does failover and which places it sends different methods to and so on. Yeah? Testing strategies. I think tests are important. I'll tell you what. I'll show you a quick demo. So let's see. OK, so in Chrome, let me kill that. And so in my Meteor checkout, we don't have app-level tests yet. It's important. We're just not there. But we do have a lot of tests for the framework. So I'll just show you how that works. So Meteor is this collection of what we call smart packages. So every component is a package, and that's the directory of everything in the repository right now. I can actually run Meteor inside a package directory to run its tests. So if I come over here, we should see all of the tests that are running for my packages. And some of them take a while because there's timeouts that we're testing and so on. But we have all tests passed. And actually, let me go into a particular package like mini-Mongo. So this is the JavaScript implementation of the Mongo API that runs in the browser. And again, I'll run Meteor. And we should just see the mini-Mongo tests come up in a second. So there's my Mongo test. So I'm a developer, and I'm working on the mini-Mongo package. Here's the implementation of our Mongo database. And I'm just thinking, what could we break? Count. Okay, so you can ask how many things match a query cursor, right? So let's just always return 0 for the count. So I save my file, and because we have hot code push, there's my broken test. And what's really cool is if I click on one, oh, well, if I had my inspector up, I'm sorry for the horrible UI here for a second, but if I click on a test that's broken, it drops me right into the debugger where I went wrong. So this is the strategy we're going to follow, right? Tests ought to be real time. It's hot code push just like everything else. So you've got a window. You're all going to want to buy 2 monitors. You got a window with your app, and then you got another window with your test suite. And just as you change your JavaScript and as you change your HTML and you write tests for it, you'll just see those things update in real time as you make changes. We've found that invaluable for writing apps. So we're just trying to find the right way to bring it into the app level testing and not just the packages. Anything else?
Selection you have right now for different databases you can use, or perhaps are there other templating languages that I could use on the front end as well?
So the question is other databases or other templating. You don't think Mongo and handlebars are the end of the world?
I like Couch.
You like Couch. I do too. So we've designed this to be database agnostic. The protocol I showed you on the wire doesn't care, right? There's just attributes with primary keys and table names. You can map Couch to that. You can map SQL to that. What you have to write is a layer between that protocol and the specific database API. That's not too bad. So the Mongo live data package is what does that for Mongo. And we'll do others, but we'd love pull requests if you want to go into that. The other thing you probably want to build in the Couch example is implement the Couch API in JavaScript to run in the browser so that you can write the same code with the same APIs on both sides of the wire. That's optional. You could have your Couch data sync into a Mongo collection on the browser, but then you just got to think in 2 different APIs for doing that. For templating, I don't think there are that many template languages. We're working on Jade, which is the other big one, or something in that style where it's more of a semantic template. To get it working is really easy. The trick is doing it efficiently because we try to re-render just the smallest pieces of each template that we can. And that just requires some subtlety around keeping track of each DOM element and how the template engine works. So it's coming. Yes?
So in your example, you have all of your JavaScript for the server and for the client in one file.
Yep.
What actually gets delivered to the browser? And
Sure.
people, I guess you wouldn't want some.
I'd better delete that line. So the question is, what's getting sent to the browser and what's not, and everything I had in one file in this demo. So this file is actually getting sent to the browser in its entirety. So that's not how I think you would structure a larger app. We've stayed away from the decision about exactly how to structure things so far. If you put files under /server, they'll only go to the server. So there are ways to segregate it where you do segregate the code. What's really coming is some kind of asynchronous module delivery for sure, because I think you're not going to want to send your administrative JavaScript code to a client that's not auth to do admin. We're just not there yet, so it'll come. I think this is the last question.
It seems like you've got a really nice spec for a REST API here.
Yeah.
Sort of listed in the app. That's, a great way when people are trying to interact with your app. Like, well, where's the REST API? Would you consider generating that at some point in the future or supporting plugins?
The question is REST APIs. Like, will a Meteor server speak REST? Yes. I mean, I think a publish function is a very natural get endpoint. It's going to be a snapshot, not a stream. But that's absolutely coming. I think there's a lot of sugar we can build. And our philosophy was to build the low-level underlying technology to make this work and then start adding on top of that. So when you define a collection, you'll be able to say, I would like this to be accessible as a REST endpoint. And methods translate very nicely into posts, right? So you can say the add to score is going to be a post where you can have a legacy client connecting and making that change. Yeah. Thanks, everybody.